In this video, we're going to continue looking at the Gin and Juice shop, which is an intentionally vulnerable website created by Portswigger for you to test a web app vulnerability scanner. So I just want to give a quick recap of the previous video. I would encourage you to go back and watch it if you haven't already, because the series is going to follow on from there. And that was basically looking at how Burp Suite works, how we can use each one of these different tabs and what the key features are, but also how we can run a scan and then generate a report. And the rest of the series is going to be based on the vulnerabilities that we found in the scan. So yeah, I would encourage you to go back if you're not sure what I'm talking about. And it was a very brief intro to Burp Suite, so if you want a more detailed introduction, I do have another video on my channel which is like 30 minutes long on how to use each one of these tabs in Burp Suite. We're going to jump into the SQL injection vulnerability very shortly. Another thing I want to do is start a live crawl here. You might remember in the previous video, we did this crawl and audit scan, and then we also set up a live audit, but we don't have a live passive crawl. And since each one of these videos will continue from the previous one, if we discover any new paths, I want the live passive crawl to automatically start exploring those. So I'm going to tick all of these. I'm going to set it to the Burp Suite scope that we already defined in the previous video, and we'll ignore the duplicates as well. And that's it. Now we've got a passive crawl that's running and also the live audit as well. Another thing that I realized since the previous video, I've still got this report open, so this was all the issues that we came across. I'm going to go through them in order of severity, so we're going to start with this SQL injection one. But I also found there's actually another endpoint on the website called vulnerabilities. And if you go to this, it will give you a list of all of the known vulnerabilities with the website, or all the intended vulnerabilities. So it tells you what the endpoint is and then what vulnerabilities are there. So it means we can always refer to this just in case there's anything we missed during our burp scan or the manual exploration we're doing. With that stuff out of the way, let's just go and have a look at the issue. So I'm over on the dashboard at the moment in Burp, and you can see all of the results that came back from the crawl and audit. And our SQL injections are in there. So we've got one at 10:57 and one at 11:07. If you click on one of those, it will take you to the issue, and then we can have a look at the advisory, which will tell you all about it. If you already know what SQL injection is, this is probably going to be stuff that you know. What I'm mostly interested in is the requests and the responses. And just to mention, you can also get this in the target. So we've got the target here with our Gin and Juice shop, and on the right, you can see the issues. And I can just select one. It tells me straight away that the endpoint is catalog and the parameter is category. And we can have a look at the requests here as well. So very similar. We just want to see, this is what was injected. You can see the single quote, and then the response came back as a 500. And then the second request they sent had 2 quotes, and the response came back as 200 OK. You can have a look at the path to the issue, which is going to break this down. So what was the URL? How do you actually recreate the vulnerability? We click on products, then we click on juice. Let's have a look at the second one as well. So this was a value as a JSON parameter, which is base64 encoded in the tracking ID cookie. And again, you can see this, it's highlighted the problematic value, which is this tracking ID. It's URL encoded. I can see that by the percentage 3D at the end, which is an equal sign. And then this looks like base64, which makes sense because it's just told us that it's a base64 encoded value. And similarly, we have our first response comes back with the 500, the second one comes back with the 200, but we can't actually see what the difference is. So we need to go and actually decode this cookie. So I'll take a copy of this one, and you can go to CyberChef or something, or you can just do it in the terminal. So if we echo that value, and then we can pipe that through to base64-D to decode it. And here is our JSON object, which has a key called type, which is class, and then the value is this value, and you can see it has these 2 quotes in it. So now we know if we want to go and test this, how we're going to recreate the vulnerability. We'll be able to play around with this payload and then re-encode it into base64 and then assign it to that cookie value. There's quite a few steps there, so let's save that one for later. Let's just go back to the first one, and we have the first request. I'm going to just right-click this and say request in browser. And then you can just tick this to say you don't want it to ask you in future. In future, it'll just copy to the clipboard, and then we can just paste this in and see what it looks like. Okay, it looks like we would expect based on the results of the scan, but what about if we put in a second quote? Now it comes back with no results are found, but it wasn't an error because we've closed off the quote. So what we want to do here is try and put in a value which is going to test a condition. So instead of just having a quote here, let's put in a quote and say or, and then another quote, and then 1, another quote, equals quote 1. There we go. We refresh the page and it's come back with a lot of products. Now what happens if we change this to 1 equals 2? It's reloaded, but it's only come back with the juice products this time. So let's try and visualize what this SQL statement might look like on the back end. I'm going to open up a new file called new.sql and let us minimize this so we can see the URL at the same time. What's likely to be happening on the back end whenever we search for some products is something like this. We say we want to select all from products where the name is equal to, and then it's going to be whatever we put in. So let's just call this user search. And that's the value that we're searching for. Actually, let me go back here because I'm not currently searching for a product. Doesn't make much sense. There we go. Okay, so juice. So now the search term is ABC. We change that search term, and the category is whatever we just specified. So the category is equal to, and we put in juice, but I'm just going to put in here search category. So what's happening when we make this search? It is selecting all rows from the products table where the name column is equal to the search term we provide, and the category is equal to the category we provide. So if we search a term which exists in the products database and it matches the category we search, it'll bring back the result. However, what if we then inject something here? So our search category is currently juice. Let's actually update that. Let's say that we put in here juice, and then we insert a quote. So now this is not a correct statement. We've got two quotes at the end. But if I insert some other logic in here and say or 1 equals 1. So it's saying select all rows from the products table where the name and the category match what we've put, or 1 equals 1. Obviously, 1 will always equal 1, so it's always going to return all of the results. And if we change that to or 1 equals 2, this is never going to be true, which basically just means it'll carry on using this condition. Hopefully that makes sense. At this point, maybe we would start using SQLMap either in the command line or through a burp extension or some other kind of automated tool, or we'll make a custom SQL script or something like that. But for the purposes of this video, I think it's a good idea for us to manually probe the vulnerability and try and understand what's happening. So we want to enumerate the database, and Portswigger has some great material on their Web Security Academy on how to do this. So once you've found your SQL injection, you can check out their cheat sheet on how to identify the backend technology, the version, and the kind of syntax the database likes. Payloads All the Things also has a great Git repo, which has a lot of different injection payloads, not just for SQL injection, and I use that quite regularly. Actually, before we start enumerating, let us talk about the different types of SQL injection attacks as well. So we already saw there, let's take this out, let's just search for nothing, and we have this or 1 equals 1. So if this was like a users table in a database, we would be able to say that 1 equals 1 condition in order to retrieve all of the users on the table. However, there's nothing of use in this products table. There's nothing that we're interested in which is useful for an attacker. So we need to think of another way to extract that data. And that could either be with a union attack where we basically grab data from another table and then combine it with the data that's being grabbed from the product table. Or there is a blind attack. So we'll look at both of those. Let's start off with the easiest one and the preferable one, which is the union attack. And the reason being because it'll be a lot easier to visualize the data that we get back from the database. We want to try and work out what the comment syntax is. So you'll see this in the Portswigger cheat sheet that the hash symbol is quite common and also a dash dash. The way I'm going to test this is I'm going to put in these two apostrophes, which will cause the... Oh, I thought it was going to cause our error. Oh, sorry, one apostrophe will cause the error, two will fix it. So one is going to cause error, but what if we do one and then do a hash symbol? Is that going to comment out the rest of the statement and stop the error? It doesn't. What about if we do a dash dash? And this time it does. So we've just confirmed that that is the correct syntax for the commenting. Just to visualize what that would look like then, if we provide the juice here and then we provide another quote, at the moment, that is going to cause an error. Let me actually take this out. I have to assume that there are quotes all around this. I should have put these in to begin with. So there's quotes all around this. And because we've just injected a quote here, it no longer closes off properly. But if we do the dash dash, it's now commented this out. So the statement simply looks like this. Okay, we found out the correct comment syntax. That's great because now we can identify the number of columns. And this will be useful for the union attack because if we want to combine data from another table, we need to know how many columns we're merging it into. So to do this, we can simply do order by. So we've got a quote in here. We're now saying order by 1. And then we put in our comment at the end. and we want to see what comes back here. Juice order by 1. Let's try and do order by 10. And now we get an error. Okay, let's do 5. 5 doesn't cause an error, so there's somewhere between 5 and 10 which has caused an error. Let's do 9. We get an error. Okay, let's do 7. We don't get an error. Let's do 8. And we don't get an error. So we get an error at 9, and we don't get an error at 8, which indicates that there are 8 columns in the SQL statement. So that's just a classic binary search where we start with a low number and then a high number, and then we go to the middle and keep dividing by 2 rather than just looping through every single number. Although you could very easily just do this with burp intruder or your brute forcer of choice and just loop through all of the values until you get that 500 server error. And there you know you're trying to order by too many columns, because you're basically saying, if we change this to 9, we're saying order by 9, but the 9th column doesn't exist, so we get that error. This means we can now try our union attack. So I'm going to go here, I'm going to change this and say we want to union, and then we'll select, and I'm going to put in here null, and I'm just going to do this several times. We had 8 columns, right? So that's 2, 3, 4, 5, 6, 7, 8. And if we hit enter, there we go, all looks good. What happens if we put in a 9th column? We get an error. What happens if we do 7 columns? We also get an error. So notice that it has to be exactly 8 columns in order for this to load. Obviously, this is no use to us. We don't want to just retrieve null. We probably want to look for some strings, most likely passwords or credit card numbers or something like that if this was a real attack. But first, we need to work out what data types these columns are as well. If we want to load a password, it's likely to be a string, and we need to make sure the column can deal with the string. So what happens if I change this to an A and try to load it? It comes back, okay, so it didn't work. Let's do the second one. And this one does work. Okay, we could also try the third one. The third one works, and you can actually see it has returned A. So I think that's the one I'm going to use. And the fourth one causes an error. Okay, so let's change this back. Let's do the third one is going to be the target, and then we'll just have the rest set to null. So now I want to try and find out what databases exist, and then what tables exist in those, and what columns exist in those, etc. And again, we can look at our cheat sheet and try some different syntaxes. The one that we want to use here is the schema name. So I'm going to change this to schema name, actually take out the quotes. So we're selecting null, null, and then schema name, and then null, 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 null. And we want to select it from the information schema dot schemata. Make sure it's commented out at the end. We load that, and look what we get back. We've got 2 databases. One is the information schema, where we just loaded this from, and the second is called public. Another thing to mention here is sometimes if this only retrieves one thing at a time, you'll need to use a limit here where you say limit one result, and then you'll need to enumerate through each index. A way that you can often get around that is to use group underscore concat, and then you can basically put in like the schema. If you can type it, then you can put in the schema name, and this will merge it into the single result. So if it was only returning one product, basically, then we wouldn't need to loop through each item in the table. We could just concatenate them into one result. So let's try and find out what tables are in this public database then. I'm going to change this to say that we want to grab the table name, and this time it'll be from the information schema tables, where the table schema is equal to public. You can find all of this on Portswigger or on Payloads All the Things. This is just how we interact with the database, and the information schema has a standard format. So if you find the same database type in future CTFs or bug bounty or stuff like that, then the format should be the same. Anyway, that returns 3 tables. We've got products, we've got tracking, and we've got users. So we've drilled down into the tables. Let's drill down into the columns as well. So I'm going to do column name, and this time it's going to be from information schema columns, where the table schema is public still, and the table name is users. And there we go. We've got the 3 columns: email, password, and username. So you can guess what we're going to do now. We're going to say we want to union select, and this time we're going to select username, and we're going to select it from public.users. And there we go, we've got the user Carlos. Now, the next thing we do is try and do the password. And there we go, we've got Hunter2, and let's try the email as well. And it didn't come back with an email, but we got the username and the password nonetheless. Maybe we can also get them all in one. Let's try and do username, password as these. Oh, it wasn't that one, it was this one. I'm not too sure where that is being retrieved to. Oh well, we have verified that the union attack works anyway. You can explore some of the other databases in your own time and see if there's anything else of interest there. For now, let's look at what we would have done if there was no possibility for a union attack. So imagine that no data is loaded from the database to the page. It's simply a query which is done on the back end. In that case, we would call it a blind SQL injection vulnerability. And in order to extract data, we're going to need to do something like look at the timing, or look at the errors, or look at some conditions. So we know at the moment that if we search for some product, it'll come back with a result or it won't, depending on whether or not it exists. But we can also leverage that and say we want it to return a product if some condition meets true. So for example, if the first character of Carlos's password is equal to H, then we want you to load the results. But if it's not, we don't want you to load anything. So you can imagine how you could cycle through that. Another way is with timing. So we could say we want you to wait for 10 seconds if the first letter of Carlos's password is H, otherwise just bring it back straight away. And then you can basically just loop through every character and try and work out what the password is. Another option is to use an out-of-band attack. So you could use burp collaborator and use that to make a callback from the SQL server. So to get an idea of how that might work, let us test it out. What we'll say here is we'll try and find out first of all what the length of the database name is. So let's say and then the length. Again, syntax just taken from either documentation on Portswigger or payloads, all the things, or whatever your resource of choice is for SQL injection. And we're going to ask it, is the length of the database greater than 1? And it comes back with a 500. Let us change that and say, oh, actually, I know why it did, because we didn't have a comment. So the statement didn't make any sense because the rest of the statement was still in there. But that works okay. Let's try and change that to a 10. And now it says no results found. So it's basically saying that condition is false, right? So if we change this and say, actually, it's less than, it will come back with these results. So this is confirming that the name of the database is less than 10 characters. And again, we can just do the same thing. We can go back and say, is it less than 5? There's no results. Okay, so it must be somewhere in between 5 and 10. So let's do 7. Is it less than 7? It's not. Okay, is it less than 8? It's not. Is it less than 9? It's not. Okay, is it less than 10? It is, which means it must then equal 9. So we'll just confirm that by changing it to an equal sign and setting it to 9. And there we go. We've confirmed that the name of the database is 9 characters long. Now, obviously, we want to extract data. We don't just want to know how long the name fields are and how long the database and the column names and all that are. We want to know what they're called, and eventually we'll want to know what the passwords in the user table are. So how are we going to extract that? Well, I'm going to change this. Instead of checking for the length this time, what we'll do is we'll look for the substring and we'll specify an index. But for now, let me just do, in fact, yeah, let's do our substring, and then we'll say 1 and 1. So we're selecting the first element and we're just checking the first character basically. If I change this to 5, it's going to compare the first 5 characters. So we're just doing 1 to 1, and we want to ask then what it's above. So again, we'll say, is it greater than 1? But at the moment, it's not going to be the right data type, so we'll also want to convert it. Let me change it to ASCII, and I think this will work for us. So is it greater than 1? It looks like it is because it's come back with the results. Is it greater than 100? Not. Okay, so again, we would say, is it greater than, let's say, 80? Bearing in mind, these are ASCII values, so you'll need to find out what that maps to in terms of the actual character. And you can probably imagine this is a very slow task, especially if you have a lot of databases, a lot of tables, a lot of columns, and a lot of rows. So a more sensible way to do this would be to automate it with something like the intruder. Let me try and find the request we were just dealing with. So it's in our HTTP history, and it's this one. I'm going to send it to the intruder. And you have different attack types here. The sniper is going to take one set of payloads, and we'll try and use this first of all. So, oh, it put our value into the cookie, which I don't remember it being in there. I'm going to take that out for now. So you might want to URL decode this so you can read it a little bit easier. You can do Control Shift and U, or you can right click and URL decode. And what we're going to do here is loop through this ASCII value. So I'm going to add these little markers here, and that's it. We're just looking for the first one. So again, I'll do Control and U to URL encode that. And let's go and set up a payload. So we're going to use numbers, and we're going to use the ASCII range. The lowercase is 97 to 122, and the uppercase is 65 to 90. So I'm going to start at 65, and then I'm going to go up to 122. So we're doing all uppercase, all lowercase, and I think all the numbers are in there as well. We're stepping over one at a time, and I think that's good. Let us do start attack. So it's looping through, and I guess we'd want to have a look here then at the length of some of these responses and try and work out which one is correct and which isn't. Or you can find out what is the condition. So whenever we put in something which isn't correct, it says sorry. So what I'll do is I'll actually flag this. I'll go into the settings, and we'll say that we want to match any responses that say sorry. I'll add that. Let's go back to the results, and here we go. So we have actually quite a lot of results that didn't match that. Oh, of course, it's because we use a greater than sign. We're not looking to do that actually. We want to use the equals sign. So because we're automating it now, we can just jump straight to the equals. And I'm also going to change the settings here, so I don't need to do this each time. So let me just do that grep and match and say that we want to match sorry. We'll add it, and then we'll start the attack again. Going to loop through, and it comes back with 76, so we can go and find out what that is in ASCII. I should have really had something open. Let's go to CyberChef, and we'll put in here 76. We're going from decimal, and it's an L. Okay, cool. So that's it. We can now go back. We'll close this down, and we'll say what is the second string, the second character in the string. And again, we're just looking for one that does not have a sorry in the response. This time it is a 79. So there we go, 79 is O. And we can keep looping through all 9 characters. We will find out that, in fact, I'll not say what we'll find out, because let's try and do this a smarter way. So a smarter way to do this would be to use a cluster bomb attack. So this will use multiple payload sets, and it will iterate through each payload set in turn. So if we basically want to say, let's loop through here 1 to 9, it'll loop through, it'll start at 1, and it'll go through every possible character. Then it'll go to the second index and then go through every possible character. It'll go to the third index through every possible character. As opposed to some of the others, for example, if you look at the pitchfork, it will use different ones, but it would do the first index with the first character, and then the second index with the second character, and then the third index with the third character, etc. We want to do each index at a time. So yeah, we'll change this to cluster bomb. We'll add another marker here. I'm going to change that back to 1. Let's just start off at the beginning. And we'll go to our payloads. We now need to do 2 of these. So I'm going to change in fact, we need to keep this for the second payload now. So 65 to 122 is numbers. 65 to 122. And then our first payload is going to be just looping through 1 to 9, which is the number of characters in the database name. And again, we want to match the ones that have that sorry in them. And I think that's good. Let's do start. It's going to loop through. Again, we can sort these. And you can see it's already picking up all of these. But it's not easy to work out the order here, because if we try to now sort it by the payload, it's also going to give us all of these invalid responses. So what I like to do here is filter it by the by the sorry message. And then we can right click it, and we can either do add comment or highlights. And then if you do, let's say highlight, and now we can do filter and say show only highlighted items. So it now only has our correct values. And now we can sort it by the payload number. And we can basically go through. Let's go over to CyberChef. Oh, okay, here we go. Let's do it. So it is 76, 79, 67, 65, 76, 72, 79, 83, 84. There we go. We found out that the database name is localhost. That's it. You can basically repeat this then and enumerate the whole database. I'm just going to paste in another payload that I used the other day when I was testing this out. So we can say that we want to select the table names from the schema.tables, limit it to the first result, and then we could basically loop through each one of the results here. And it's just basically the same process. If we follow that and then go to the sorry, it'll loop through all of those In fact, it's only doing one table name at a time because we've limited it to one result. But the same thing here, we could just right click it. We'd say, let's do the comment this time. We'll say add comment, add a random comment, and then filter and say show only commented items. And now we can do it by the payload. And let's just one more time, we'll go over to CyberChef and type these in. So 69, 78, 85, 77, 95, 86, 65, 76, 85. And there we go. There is the first one, which is enum value. Oh, I've only done up to 9 characters as well. So you'd want to increase this and say like up to 20 or 30 or something like that. Or you could also find out what the actual lengths are before you enumerate the values. That's actually something I did for the DVWA video series. I made a blind script that you can basically loop through and extract all of the lengths of all the table names, the column names, things like that, and then extract the values knowing what the lengths are. Okay, we've already been through quite a lot, and this video is getting too long for my liking because I'm going to have to edit it later. So I just want to talk about the other SQL injection vulnerability that was found. It was the one in, I can't find it now, let's go to target. Yeah, it was this one in the JSON parameter. So I was kind of hoping to be able to demonstrate some automation with this as well. I'll send this to the intruder. And one thing you can do in the intruder or repeater or whatever, you can right click on this and say that you want to convert it, and then we'll do base64 decode. This one's URL encoded because of that equal sign at the end. So we first need to do we can do base64 URL decode. Oh, that also didn't work. That's strange. Let me try it without the equals at the end. Decode. Okay, that did work. So yeah, you could decode this and then you could modify it and then re-encode it. But I was really hoping to automate this whole process doing something like we just did. And let me take an example. So let's say that we wanted to loop through and extract those values again. So we're doing each of the indexes and we're trying to get all the table names, just the exact attack that we just did. And this would be fine. The only problem is we need to base64 encode this value. And I wasn't too sure how to get around this. It would be nice if we could just do an add here and then we have we're looping through these two values, but then the overall value, we process it with some encoding, but I couldn't find a way to do that. The other thing is if we go to, let's do the cluster bomb, go to payloads, there is a payloads processing option, and we can basically say in here we want to encode it, and then you can do base64 encode. The problem is it's going to encode these payloads. It's either going to encode this number here or this number here. It's not going to encode this whole JSON object. So the other thing I was thinking is, well, we can just use macros and some session handling. But unfortunately, I still had some problems doing that as well. So let me see here. If we go to sessions, if we go into sessions, we can basically set up macros here. And I have used this to do some cool things in the past. The problem is if we go and select our target, I think it is this one. It has the tracking ID in it. So we can select this one. Or actually, a better thing we could do is we'll send this through to the repeater, and let me just see if I click send now, will this also show up in here? So we'll delete that macro. Let me try and add a new one. And I'm looking for that request. What was the timing of it? Okay, it wasn't that one. I did find a way to show this in here. I know a way we can do it. I'll right click this and then I'll do request in browser. We'll paste this in here. We'll go back to our settings, and now it will show up in here. Yep, there we go. So that's it showing up. So I would basically select this one and then click on OK. And then in here we can configure item, but it's only allowing us to change the category parameter. There's no option to mess with the cookie, and these don't do anything here. And then this option is to modify the response, which again is no interest of us. We want to modify the request before it's sent. So I can't find a way to do this. Hopefully that would be the way to do it. You'd create a macro which will, every time you send a request, every time the intruder sends a request, it will automatically base64 encode that cookie. And you would then just use a session handling rule here to say, okay, we want to run that macro each time. But again, it doesn't work because we can't actually update that cookie value. And I had looked through these as well, setting specific cookie. Yeah, you can set a cookie, but there's nothing in here to like base64 encode it. So literally the only other way I can think of doing this is to write a custom extension, which is just pointless. You might as well just use a custom Python script or move over to SQLMap or something like that. So if anybody works out a good way to do this, maybe I'm missing some tricks with the macros or the session handling. It's been a while since I set this sort of stuff up. Or if you find another way to exploit this, maybe you just come up with some cool script which is going to do all the base64 encoding and decoding. And if you do, leave a link in the description to your GitHub link or whatever. I'd be interested to check it out. Okay, the final thing is you can also use SQLMap. So if we go to our extensions here, you can install the extension for SQLMap, which is right here. So let's tick that. It's going to load it. We can go to the extension now. You need to start the API. And once the API is running, you can see we have the scanner. So you could input all of this information, or we can go back to our intruder or a repeater. And I want to get the request that's not modified with our JSON object. So let me send this one to the repeater. And let's take this cookie out. It's the tracking ID we were interested in. Oh, but also this one up here. So, okay, let me just take this out as well. It doesn't like the tainted values in SQLMap, so you shouldn't try to put in like quotes and stuff. Just let it work all of that out. And we can right-click this then, go to extensions, send it to the SQLMap scan, and then it'll just populate all of that information, and we can just start the scan. However, it didn't come back with anything for me. I didn't get any logs. And if we go to the extensions and into output, you'll see that there are some errors in here, basically. Not errors, but it's failing to come back with anything. And I'd rather just verify this in the command line. So let me take a copy of the request and let's do Sublime new.request. We can paste this in and then do SQLMap -R to take in the new request, and then --batch just so it doesn't ask me any questions. It'll just say yes to everything and it'll loop through here. But it didn't get any results for me. What was happening is it couldn't find the version of the database and basically didn't know how to proceed. And I believe that was due to it getting 500 errors. So you see here, so it's found the SQL injection. It says it's got a Boolean-based blind, and you could go and verify this by pasting this in to the browser. It's just the same thing that we were doing, but it doesn't find the database version, and therefore it just gives up. And it comes up with this bad request and 500 internal server error. But we know that's what happens. Whenever we put in an invalid value, it comes up with the internal server error. So I kind of hoped that we'd be able to set that as like ignored. So if we do, hang on, let's do grep-I code. So there is some options to say that you want to match a HTTP code. So for us, 200 is true, whereas the 500 is an error. It's not really false. You can also say you want to ignore the code, but yeah, I played around with this stuff. It didn't work for me. If somebody works out how to get this to correctly identify the version, or just so that it runs without stopping due to those 500 errors, then I would be interested to hear that. I'm assuming that Portswigger have specifically designed this to not work with SQLMap, but I may be wrong. Anyway, that is going to wrap it up for this video. So today we have looked at the 2 SQL injection issues, and that includes manual verification of the vulnerabilities. We did some database enumeration. We looked at union and blind injection attacks and how we can automate some of that with burp intruder. And we also looked at some issues around automating more complex attacks that don't work well due to macro issues or my skill issues, I don't know, and also the SQLMap as well. In the next video, we'll look at the second highest vulnerability on the list, which was XML, external entity injection. And I hope you've enjoyed this video. If you have any questions or comments, as ever, leave them down below. Thanks.